Hello everyone. Today we would like to speak about how to make a stackable surgical guide using ImplaStation Beta version. ProDigitant, a dentistry-centric solution and service provider, has established a whole series of digital products, focusing on customer needs, providing integrated solutions for dental practitioners and dental technicians around the globe. The software, ImplaStation, is intended for implant planning and surgical guide design. The main concept promoted by our company is the creation of a free and accessible platform based on our software for dental treatment planning and sharing information among team members worldwide. ProDigitant Lab is a virtual digital service dental laboratory providing a global service. This is a progressive, established laboratory with over 5 years of experience base doing this with a wealth of knowledge and an esteemed reputation in digital implant planning and surgical guide design. We place value on quality. Our business processes are certified according to ISO 13485 and ISO 9001. ProDigitant is proud to announce that on December 3, 2021, the FDA, U.S. Food and Drug Administration, granted 510(k) market clearance for the sale of the ImplaStation software in the United States. Various designs are developed according to the type of guide support, including tooth-supported, mucosa-supported, and bone-supported surgical guides. The bone-supported surgical guides are commonly applied to patients who need more extensive bone surgery. Therefore, the reflected flap may make the correct intraoperative positioning of the guide more difficult. The tissue-supported surgical guides are mainly used for total edentulous patients, and the resilience and the thickness of the mucosa may affect the correct seating of the surgical guide. Stabilized by the wide-ranging remaining teeth, the tooth-supported surgical guides are commonly applied to a tooth gap with limited missing teeth compared to the mucosa-supported and bone-supported surgical guides. This rigid support from the teeth provides a sound basis for the correct intraoral seating of the guide, which is of prime importance to attain accuracy. A relatively new type of surgical guide is the stackable guide. The stackable surgical guide derived from a digital workflow increases the predictability of the performance of bone reduction, immediate implant placement, and immediate loading of provisional implant-supported fixed dental prostheses. Benefits of stackable guide. Predictable surgery is an uncomplicated and highly methodical approach to guided surgery. Guided bone reduction. Prosthetically driven plan ensures ideal guided bone reduction to accurately transfer the simulated plan to the patient. The use of a bone reduction guide during surgery eliminates the arbitrary removal of osseous structure and helps ensure the mandibular crest is reduced in prescribed dimensions, eliminating only the sharp edge of the knife ridge. Precise planned placement. Osteotomy guide facilitates accurate implant depth and trajectory. Guided implant placement could significantly shorten procedure and anesthesia time. The main benefits are that using stackable surgical guides in patients undergoing guided full-arch teeth replacement shortened procedure and anesthesia time and anesthesia recovery time, as compared with regular full-arch teeth replacement. Let's talk about parts of the stackable guide. The fixation base's initial function is bone reduction. The upper edge of the fixation base is created to indicate the level to which the bone needs to be reduced. The second function of the fixation base is to support the components: osteotomy guide, carrier guide, PMMA, ceramic or provisional, prosthetic. Pin guide. Pin guide's only purpose is to deliver the fixation base and maintain its position while the fixation pins are set. Dentate pin guides seat on the teeth are verified via revision windows and ensure the surgery starts in the correct position. With edentulous patients, the pin guide will seat exactly like the denture and verify the bite and ultimate tooth position. Osteotomy guide controls the implant depth, trajectory, and indexing, rotation, during osteotomy creation. It seats into the fixation base and is fixed using locks. Carrier guide. One function of the carrier guide is to serve as a tissue gap between the top of the bone reduction to the bottom of the prosthetic. The carrier guide remains in the mouth through the prosthetic conversion. The 2 or 3 clear plastic pegs on the carrier guide deliver the prosthetic in the proper position as planned. Provisional prosthetic. The provisional is a strong and aesthetic prototype for the final restoration. It is designed for immediate load and extended use. The provisional is delivered the day of surgery and remains in use until the final prosthetic delivery. Diagnostic phase and case planning phase. Guided implant surgery uses a planning software that enables matching, or the overlaying of radiological data, DICOM file, and clinical patient data, STL file. The CBCT data can be analyzed to determine the most appropriate treatment alternatives based upon the bone quality and bone density. Utilizing ImplaStation software, the diagnostic information for implant planning can be fully appreciated in all of the necessary views, including cross-sectional, coronal, sagittal and axial, and in 3D reconstructed surface models. The diagnostic phase is greatly enhanced when the existing intraoral condition can be captured with either an analog or a digital method. The fully digital method utilizes an intraoral scanner to directly digitize the oral condition. Restorative space info, intraoral retracted views and smiles are often required to complete case planning. Through the process of segmentation, a surface model can be reconstructed from the DICOM of the existing patient's denture, using dual scan technique. You can create surgical stackable guides with ImplaStation if the beta version of the software is uploaded and activated on your computer. Let's look at the typical workflow of a stackable guide design. In this patient case, a digital workflow allows us to have an efficient and predictable treatment protocol for the immediate implant placement and the prosthetic restoration design prior to the surgery. The treatment plan consists of extraction of all the remaining teeth of the maxilla and restoration of the full arch with the all-on-4 concept. Click Surgical Guides in the Tab panel menu to open the tab. In this window, click Make Stackable Surgical Guide to open the Surgical Guide Settings menu. Define the borders of the surgical guide by clicking the scanning surface along the desired margin line. Then double-click to close a surgical guide margin line. Now you can move points on a margin line by dragging and moving them with your mouse. Using the Surgical Guide Settings menu, you can define settings for the surgical guide and its representation in the 3D rendering view. Step 1. Select a surgical guide insertion direction, mandible, maxilla. Use the guide offset, thickness, and side angle settings to define the design properties of the surgical guide. Select High Palette if the palette is unusually high and narrow. Select Smooth Surface for smoothing the top of the guide surface. In step windows, clicking Next Step saves the settings for this work step and takes you to the next step. Clicking Cancel closes the window but discards all settings specified since you have started the step. Step 2. Using the Fixation Base, Bone Reduction Guide, Pin Guide and Carrier Guide settings menu for the surgical guide, select a bone reduction guide surface design, planes, or curve. Use the Guide Height settings to define the height of the fixation base. Use the Carrier Guide Height settings to define the height of the carrier guide. You can also reset the default values for the fixation base height, 5 mm, and carrier guide height, 3 mm. Use the sliders STL and Guide Transparency to define the STL and guide surface opacity. In the step window, clicking Back returns you to the previous step. In step windows, clicking Next Step saves the settings for this work step and takes you to the next step. Step 3. Using the Osteotomy Guide, carrier guide, prosthetic settings menu for the surgical guide. The edge of the fixation base is created to indicate the level to which the bone needs to be reduced. If you want to use the bone reduction option, select the Bone Reduction checkbox. Select the surface you will use for the osteotomy guide from the list of the STL. Use the Thickness settings to define the thickness of the osteotomy guide. Use the Offset from Bone settings to define the offset from bone for the osteotomy guide. Select the desired osteotomy guide type using the two checkboxes, Solid and On Bars, on lock-supported pontics. Select the desired prosthetic type using the corresponding checkboxes. Select the surface you will use for the prosthetic from the list of the STL. Select the checkbox and the prosthetic will be cut off automatically and will be based on the position and shape of the surface you selected in the bone reduction settings when finalizing the surgical guide design. Step 4. Osteotomy guide settings. Use the Sleeve Support Diameter settings to define the diameter of the implant sleeve support. Use the Handpiece Contact Area Diameter settings to define the diameter of the contact area. Use the Sleeve Safety Zone Height settings to define the sleeve safety zone height of the implant sleeve support. Use the Offset from Sleeve settings to define the offset between the sleeve and the inner surface of the implant sleeve support. In this step, you define the pin position. Select and refine the pin position by moving and/or rotating the pin. Use the Sleeve Support Diameter settings to define the diameter of the pin sleeve support. Use the Handpiece Contact Area Diameter settings to define the diameter of the contact area. Use the Sleeve Safety Zone Height settings to define the sleeve safety zone height of the pin sleeve support. Use the Offset from Sleeve settings to define the offset between the sleeve and the inner surface of the pin sleeve support. Select the lock. Move the cursor to the desired position on the fixation base with your mouse and left-click to set the lock. Once you have set a lock position, you can still change its position by dragging it with your mouse. To delete a lock, click the right mouse button on the lock and then delete. Using the Locks menu, you can load the different types of locks. Click Load from Server, select checkbox and click OK. If you want to add your own lock files, use Add to Library button to add a custom STL file of the lock from your PC. Enter the section name, model name, and you can choose the color of the STL file. Then import STL files of the base surface, shank surface and hole, the subtraction body, from a selected source using the Import STL buttons. Step 5. Osteotomy guide settings. This step is only available if you have selected the option On Bars in the Osteotomy Guide Settings Step 3. Use the Diameter settings to define the diameter of the lock-supported pontic. Click a position at the sleeve support area, and when you move your mouse away from this point, a purple solid bar is displayed between the pink point and the mouse cursor position. Click a position at the desired surface to set the bar at this selected area. Now you can change the shape and diameter of the pontic by dragging points and scrolling the mouse wheel. Once you have set all pontics for the osteotomy guide, you can click Proceed and proceed with the workflow. Click Clear to abort the support pontic placement step. Step 6. Temporary cylinder area settings. You can select to set up the diameter and bottom of the holes for the multi-unit prosthetic temporary cylinders around the abutment axis. Step 7. This step is only available if you have selected the option, based on carrier guide, in the carrier guide settings Step 3. The pegs on the carrier guide deliver the provisional prosthetic in the proper position as planned. Move the cursor to the desired position on the carrier guide with your mouse and left-click to set the peg. Once you have set a peg, you can still change its position by dragging it with your mouse. To delete a peg, click the right mouse button on the peg and then delete. Use the Peg Height settings to define the height of the peg. Use the Peg Diameter settings to define the diameter of the peg basis. Use the Offset from Peg settings to define the offset between the peg and the inner surface of the provisional prosthetic. Once you have set all pegs for the carrier guide, you can click Proceed and proceed in the workflow. Click Clear to abort the peg placement step. Step 8. Support bar, label, viewing windows settings. You can add a revision windows to the surgical stackable guides surface. Select Place Viewing Window in the menu. Move the window shape to the desired position on the stackable guide surface and click to set it. To delete a revision window, right-click on it and delete. You can also add a support bar to the surgical stackable guides surface. You can add a text label to the surgical stackable guides surface. Select Place Label in the menu. Type the desired text into the text field. Using the window below the text field, you can change the depth. Move the text to the desired position on the stackable guide surface and click to set it, then proceed. To delete a text, right-click on it and delete. Step 9. Planning result files, STL files and PDF files, are created in the Planning Result Files generation and finalizing step. You can check the result and finalize the project by clicking the Move to the Project button, or clicking Back if you are in doubt or not satisfied with the result. Please be advised that your account will be charged the 3 exports. When you enter the View Surgical Protocol, ImplaStation generates the surgical protocol automatically. The surgical protocol is a PDF file that contains all relevant information about the project's defined implants and equipment. This includes information about implants and drilling sleeves, model, manufacturer, diameter, length, as well as information about surgical kits and drills, type, length. Furthermore, the surgical protocol includes patient information, name, birth date, etc. Beta updates are automatic and we continue to improve our software, fix minor bugs and add new features. Thank you for your attention.